in the torsion, then only you can call it as a torsion. So suppose you given us some circular shaft, we can able to see some torsion will happen. Please remember there is one other sometimes torsion will be the formula for the torsion for the finding doing the problems is this one. All this one formula is remember you remember this formula for doing the problems on the torsion concept. T by J, Fs by R, G theta or G phi by L, whatever may be. So, but as I said, you have to remember this formula as well as you have to understand each one of this meaning of this letter, right? T anyhow, you will easily remember torsion. But please remember torsion will be the same units of the moment, because the torsion moment or twisting moment or torsion is the same. That is Newton meter or Newton mm, whatever the units may be. And here only the people will do confusion as J. J is nothing but it is not the normal moment of inertia. We call it as a polar moment of inertia. So that we call it as a J. I is the normal moment of inertia, but J is the polar moment of inertia. If you recollect from your first year engineering mechanics, what is the difference between the normal moment of inertia, polar moment of inertia is polar moment of inertia is nothing but we have to be add both the axes, because polar moment of inertia we always talk about the three-dimensional body. Cross section is the two-dimensional or three-dimensional. So suppose this is a two-dimensional body, we need to add Ixx plus Iyy. Then we call it as a polar moment of inertia. But if you have normal moment of inertia, only we'll talk about either Ixx or Iyy based on the which axis you are finding the moment of inertia. But the polar moment of inertia, we have to add the both Ixx and Iyy. Please remember that is the main difference between the normal moment of inertia and polar moment of inertia. Sometimes they will ask simply in a bit, what is the polar moment of inertia? For a given axis, they will give Ixx, Iyy, Ixx minus Iyy, or Ixx plus Iyy. So obviously, polar moment of inertia is nothing but we have to add the both moment of inertia Ixx plus Iyy. Okay. Next, if you see, Fs is nothing but the shear stresses in the fiber, extreme fiber. But shear stresses we can able to find anywhere the torsion may everywhere you will get the shear stresses. Please remember, due to this torsion effect, you cannot get the bending stresses will develop. Always the shear stresses will develop in the torsional concept. Torsion will try to twist while happening the twist. What happens? The each fiber will try to shear off the section. Right. That's why we consider this is the shear stress will happen, not the bending stress. Normal bending moment we will get the bending stress, but torsional moment always the shear stress will happen. That's why we consider the Fs is here. Next, R, obviously R is the radius of the shaft. Whatever the radius of the circular section, it is the radius of the shaft. R is the radius of curvature. What is the radius of curvature of the shaft? And the angle of the twist is nothing but the radians. Please remember, in this formula itself, angle of twist always you will keep to in the radians. Right? Always you have to keep in the radians, not the angles. If you put the angles, if you apply the formula, you will get the answer different. So always please keep that phi is an angle of twist in radians. And length of the member you can put if you put mm, all this will be mm, and meters you put all these units in meters. That will be dependent. So you have to remember this formula for the finding the problems of torsion. The same thing if you see polar moment of inertia for a different section, sometimes you ask as a bits. Find the polar moment of a rectangular section. Find the polar moment of a circular section. Find the polar moment of square section or semicircular section or triangular section. But concept is simple. We have to be divide first, draw the two axes and x-axis and y-axis. We have to find the Ixx about the x-axis and Iyy from the y-axis. And finally, we have to add Ixx plus Iyy. You will get the J, polar moment of inertia. Right. So that is always you remember whenever they given the question, you need to draw the two axes, Ixx about this x-axis and Iyy about the y-axis, and you will get the both Ixx, Iyy. You will get the polar moment of inertia. If you see how you can able to find this rectangular Ixx, we know the formula BD cube by 12. The B is this width and D is depth for the about the x-axis. BD cube by 12, you will get the one value of the Ixx. Similarly, if you wanted to find Iyy in the vertical axis, Yy is vertical axis, dB cube by 12. D is this and B is this. dB cube by 12, you will get the one section. If you add both, you will get the polar moment of inertia, right? So you can see a difference. So if you use this, you will get the same only. Here is A and B and D are the same. So that's why you will get the only answer in terms of the A. polar moment of inertia. If you do the same thing for the rectangular section, you will get the this formula BD. Once first we will do BDQ by 12, and for the unsymmetric y direction DBQ by 12. If you get do, you will get this answer. Similarly, circular section and the other types of different sects. But normally no need to remember all, just remember four: rectangle, sorry, square, rectangle, and circular, and hollow section. So you have remember. Otherwise, if you not remember also, you can do for calculation IXS, IYY. If you add both, you will get the polar moment of inertia. Right. So this was the next thing. And yes, these are the main important people. Will many people when the confusion with the what how the practically the twisting moment happen, or how the practically the bending moment happen. Everybody know the bending moment how practically happen. If the loading is happening at here, it will try to bend. So that is a bending moment that we will know. But many people, when the faculty also don't know the practically how the twisting happen, twisting moment happen in a beam. I will now demonstrate here for you. So how practically the twisting, in which situations the twisting moment happen for a beam, right? That I will tell you. So here, if you see, this is a torsional moment is given. This is a steel section of I shape. This torsion is happened. After the torsion, it will be appears. If you see the cross section, if you cut the section after the torsion, it will appear like this. What happen is this is rotating. This beam itself is rotating. This is rotating like this. That is the torsion. As we discussed, if you rotate like this, if you rotate like this, if you see the from the cross section front view, it will appear like this. But here it is other shape. But if you see the rectangular cross section, it will be appear after twisting. So if you see after twisting, it is appearing in this beam. But if you see the normal bending moment, the cross section of the beam may not be able to change. The cross section will remain the rectangle, remain the I section after the bending moment. But only the after twisting moment only it will be sheath. The shape of the bending, the cross section also changes. That is the main difference between the normal bending and torsional bending, right? So if you see normal bending, if you cut the section cross section, it will remain the rectangle only, right? If the suppose rectangular section, if it's circle, it remains a circle. If the I section after the bending, after the beam is bending like this, if you cut the section, still it is nothing but it will appear as a I section. But if you show torsion happen, then if you cut the section, it will be shown in this shape. It is a shape. That's what the torsional moment. In other way, suppose if you see in same shape of this channel section, symmetric section, normally the load applied exactly at the symmetric point, there should not be any torsion. But due to this load, what happens? This beam undergoes the bending. Because it is a cantilever beam, free and here, when fixed it here, it will try to bending in this normal way. Now this is a cantilever beam. If you load anywhere, if you apply the load, you will get the bending. But suppose if you apply the cross section is something, the load is applied here, this will undergoes both bending as well as the torsion. Please remember, because this is not the symmetrical section, so it will undergo the bending normally, even though this load is there. But in addition to the bending, it will undergo the torsion also, torsional movement. Because this cross section is not symmetric, the load we are not applying at the centroid of that point. So that's why line of at least line of action of the centroid, it will undergo as well as the bending as the twisting. But this portion, if a load is applied at here, only bending. There should not be movement. Suppose if you see, there is a different way. There is a beam is there, cantilever beam is there. I have fixed it at one point. So this is the fixture. This is suppose this is the real practical practically happens. See, this is the structural point. This is the these are the two beams will be the horizontal. Sorry, in the both directions. If you are in a house, the beams will be the horizontal, and the both is the length and width both directions. We will get the beams. But the column is vertical. One support is one beam. Suppose if you see the beam is arrangement is like this in a building, right? So one beam is there, another beam is connected with the existing beam, but the column is supported at here. So this is a practical case. So now if you see, suppose the load is not acting, so load is if your load is acting only in the beam, so you will get only normal moment. Suppose the load is acting anywhere in the connected beam, what happens? Just imagine, because this beam is connected to beam is in this direction, so anywhere the load is acting in this connected beam, what happen? This will it will try to get the moment in this beam. Normal moment will happen in this beam, but due to this load, it will try to this how the behavior of this beam. This beam is suppose this cross beam is there. I'm applied the load. It will try to bend, right? So up to this beam, it is only bending. But if you see, due to this load upon this beam undergoes a torsion on. See, because it will be connected here, it will try to rotate at that point. Because the load is here. Please remember, load is not here, load is here. So it will try to, because there is a connectivity in between two beams, it will try to twist because the load is somewhere outside, right? It will try to twist the beam in this direction. So that beam, this beam will undergoes, the twisting. But this beam is only undergoes the bending due to this loading. Please remember. So, but this beam undergoes twisting because twisting will, please assume whenever twisting is nothing but assume it will be the twist. So this beam, this length of the beam, this beam will cause the twisting, but this beam so only the bending. So that is just is bending. But this beam twisting. Twisting means you have to assume this behavior. Cross section also it will twist. So this is the basic concept of it, torsion and the difference between torsion and the bending. Now everybody is clear what is the normal bending, what is the torsional bending or torsional moment. This is a practical example I am shown here. This is the column, this is one beam is connected and the another beam is connected to that beam, not the column. If the another beam also connected to the column, you will not get any torsion at all, even though you apply the load on that beam. But if the suppose the another beam is connected to the another beam, then what happens is the load is acting here. It will this normal beam. This beam is only getting the bending, but the connected beam, which is to connect that beam, will undergo the torsion. So see, just assume the load is here. Let's assume this load is acting. So for that, this beam try to bend in this direction. At the same time, while since it is connected to this beam, this will try to twist the beam. This beam becomes the twisting. So that we call it as a torsion. Right now it is clear. What is the torsion? What is the twisting? Everybody? Or anybody having any doubt? Please let me know. This is very important, practical knowledge. Any of faculty also don't know exactly how the torsion will happen and how the bending will happen. Right? Anybody having any doubt? Confusion, torsion and bending. But please remember, torsion is very dangerous for a beam or any structure. Normal bending is there somewhat it can resist, but torsion will have a very less capacity. If torsion is happen, that beam will fail. We cannot useful for that beam. So always the torsion is very dangerous for a structure. As far as possible, we have to avoid the torsion bending in any structure. Normal bending, okay, we can provide with the help of some reinforcement, we can able to save. But when torsion is happen, the very difficult to save that that structure. It will fail immediately after torsion. So as an engineer, you have to always such that you have a plan. So torsion will be avoided. But if sometimes we cannot able to avoid, but we can able to reduce the amount of the torsion. That we can able to. That is a engineering task. That is a true civil engineering or structural engineering job, right? So that we will see once this is the basic step. Just at this moment, just to understand what is the difference between the torsion and bending. Later, if you go to the next classes and we can learn more on this practical knowledge, right? So this is the magic topic. So here is just one more topic is there. This is nothing but the difference between the normal torsion and uniform torsion. When we call it as a torsion is uniform torsion. If the torsion applied the cross section at the rate of change of angle of twist is constant, then the member of the ends is free to wrap. Such torsion is called a uniform torsion. Just don't confuse anything but using the what is the wrap and all. Wrap is nothing but if you see if folding we call it as a wrapping. Just if anything you fold చేయడాన్ని మనం wrap అంటాం. English లో wrapping. Right? So if you see these are the wrapping, different depths of wraps. So just this is a rotating. I can say it as rotating or folding. We call it as a wrap. So these are all the shapes of wrapping we can consider. Just if you see మిల్ దగ్గర మనకి ఫోల్డ్ చేసినప్పుడు ఎలాగ ఉంటుందో దాన్ని wrapping equipment అంటాం దాన్ని. So these are the wrapping. Don't confuse with the wrap is very different thing long ways and wrap is nothing but just rotating or folding. So what happens is if the torsion is happen, when the torsion is happen, if it is uniformly entire the length, the angle is uniform, then we call it as uniform torsion. Another name of the uniform torsion is the Saint Venant torsion. We can sometimes in the gate they may confuse. Another name of the uniform torsion is Saint Venant torsion and uniform torsion and okay. It happens when the torsion angle is the same for the both direction. Then we call it as uniform torsion. Suppose only one side is torsion is happening, other is not fixed, then we consider as the non-uniform torsion. This is the difference between the uniform torsion and non-uniform torsion. Also remain the another name of the uniform torsion is Saint Venant's torsion, right? So this is another name of, sometimes this may also ask in the gate. Another name of this uniform torsion is. Otherwise, they, instead of putting this uniform torsion, they will ask what is the give the figure having the Saint Venant torsion. So they will give four different shapes. So that means uniform torsion. We have to show this is the Saint Venant torsion, nothing but the uniform torsion, twisting from the both directions. Same angle should be the same, but here is the one side is torsion. That means the angle may not be same side. So that's why it is a non-uniform torsion. So that's all from this topic. So torsion is simple. Other things are simple. Just explained in a different way. So that's all from this chapter. Torsion. I have given a main concept and the formula we can able to do. And the questions also I will share in my lecture. You do try to solve the problems of the given questions. Then you can use the same formula. The formula is the same. One formula, whichever is d by j fs by r and c theta by l. So since the lack of time, I could not able to solve all the problems here itself. So I will share this session after completion of this session. That material, please go through that whenever you free time. And only one formula you can able to solve all problems in this chapter. And also you require the concepts I have already given in my slides. Concepts. What are the concepts of shear center and torsion? What is the torsion and all? So if you can able to understand these concepts and figure, you can able to understand the concept as well as the problem.